Hello dear students. As you all know, we have completed chapter number 9, ray optics. Today we are going to study chapter number 10, wave optics. Let us start with the development of wave optics. How the wave optics has been developed. Optics means study of light. Optics means the study of light. So how the wave optics has developed, let us see. The first theory about light was corpuscular theory. It was given by Newton, and according to this, a luminous object throws out a small particles called corpuscular. Means light is basically a small particles, and those particles are called corpuscular. He explained on the basis of this theory reflection and refraction of light. Let us move ahead. Then after wave theory has come, it was given by Huygens. Basically in this chapter we are going to study this one. In this theory it was assumed that light travels in the form of waves, and it travels through a medium, or it travels through a hypothetical medium which is called ether. Later on, this medium thing was neglected because of its contradictory ideas. Then after electromagnetic wave theory was developed, it was given by Maxwell. It is there in chapter number 8. Chapter name is Electromagnetic Waves, which we will study in the future. Next there is quantum theory, that is a particle theory. It was given by Planck, and you all know that light has dual nature. You must have studied in chemistry. Light has dual nature, wave nature and particle nature. So particle theory was given by Planck. This time, in this chapter, we are going to study wave theory, and it was proposed by Huygens. So let us start the chapter. So let us start the chapter. The first thing we need to understand, what is a wave? You have studied in class 11. Wave is what? Wave is a kind of disturbance which travels through a medium. Which travels through a medium. Which travels through a medium. Okay? If a string is attached to a resistor support and it is given a slight push over here, then this vibration develops and it travels, then it reflects back from the wall and it comes like this. It goes like this and it comes back like this. Okay, so wave is what? Wave is a kind of disturbance which travels through a medium. When we study types of wave, then first we have studied matter waves. First we have studied mechanical waves. Second one is non-mechanical. And third one is matter waves. Here you have to study non-mechanical waves, the waves which do not require a medium to travel. So wave is basically what? Wave is a kind of disturbance which travels through a medium, and wave is of three types: mechanical, non-mechanical, matter wave. This non-mechanical waves are also called electromagnetic waves. Clear? So here we have to study this non-mechanical wave because light is a non-mechanical wave. It can travel in a medium as well as without the medium also. So let us come to the non-mechanical wave, that is your electromagnetic wave. The first thing we need to understand in this chapter is, we have to start writing the chapter from here, wavefront. What is a wavefront? Suppose a big pond of water is there. It is its top view. If you dip a stone over here, if you throw a stone over here, then what happens? There is a circular waves are generated, and these circular waves, they move towards the edges. These circular waves, they move towards the edges. In the same manner, light also travels. In the same manner, light travels. If a source of light is here, and light is continuously emitting from the source, then how the light travels? Light goes in this manner, in every possible direction. Okay? In every possible direction light will go. Is it clear? Now suppose there is a source of light, point source. The speed of light, let us take as v. I am taking a small time interval, that is of delta t. So when the speed is multiplied by time, what we are going to have? Distance. Okay? The speed multiplied by time is equal to what? Distance, because speed is equal to what? Distance upon time. Is it clear? So distance is equal to speed multiplied by time. Here is the source of light. Let us take a distance, this distance d, and we draw a sphere. I am drawing a circle over here, but it is a sphere. There is a difference between circle and sphere. Sphere is 3D shape, it is a football-like shape, and circle is a disc, it is a ring. Okay? So now what happens? Since the source is emitting light, the light will reach to the surface of the sphere simultaneously. Means the time taken by the light to travel from here till here, to travel from here till here, to travel from here till here, all these times are same only. All these times are same. And if light is a wave, the wave travels like this, wave travels like this, wave travels like this. So the wave travels and reaches to the surface of the sphere. All the points which are there on the surface, they start vibrating at the same time. So all the particles on the surface of the sphere, they start vibrating at the same time. Okay, then what happens? All the particles which are there on the sphere, they go up if they are vibrating. Suppose a wave is going like this. So if a particle is vibrating in this manner, so all the particles which are there on the sphere, surface of the sphere, they will go together upward from their mean position, and they'll go toward downwards together. They move simultaneously. They move upward together, they move downward together. They move upward together, they move downward together. Same happens here also. If suppose this wave is going with a speed v, if you multiply delta t, we get a d. So if we take d as its radius, suppose we get this circle, and in the wave which is produced in the surface of water, the wave is like this. This is called crust. This is called trough. And particle is vibrating in this manner. So all the particles which are there on this circle, they'll go upward together and they'll go downward together. Okay? So this particular circle, this particular sphere, this is called a wavefront. The wavefront is what? Wavefront is a locus. Locus is, suppose a point travels, point moves like this. So this path is called locus of the point. If a line moves, then it develops a plane. Okay? If a curved line moves, it develops a curved plane. So the locus of the such particles which are vibrating in the same phase. Let us define the wavefront. We define wavefront as locus of such particles which vibrate in same phase is called a wavefront. Is it clear? Locus of such particles which vibrate in same phase is called a wavefront. Let me add one more word here, and that word is continuous. Continuous locus of such particles which vibrate in same phase is called a wavefront. Now, how the wavefront is being drawn? If there is a point source of light, then what happens? Spherical wavefronts are drawn about this point. Spherical wavefronts are drawn. Okay, and the rays of light will be radial outward. So this kind of wavefront is called spherical wavefront. Spherical wavefront. When the source is a point source, then we get spherical wavefronts for the point source of light. Okay. Now, if the source is a line source of light, suppose this is your source, SS dash, everywhere the light is illuminating from the source. Now what happens? If we draw a surface which remains equidistant from the source, then the surface will be a cylindrical surface. So in this case, what we get? We get a cylindrical wavefront. If we draw so many, we get so many cylindrical wavefronts. Okay? These are the rays of light. So in this one, this wavefront is called cylindrical wave front. Okay, cylindrical wavefront. Now what happens when we move very far away from the source? Very far away. Just see what happens. This curve becomes less. Here the curve is like this, then this, then this, then this, then this, then this. So when we move very far away from the source, then what happens? The rays of light become spiral to each other. And in this case, the wavefront we get is plane wavefront. So when we move very far away from a source, then what we get? We get plane wavefront. Okay? So there are three types of wavefronts. One is spherical wavefront, second one is cylindrical wavefront, and the third one is plane wavefront. Spherical wavefronts are obtained when the source is point source of light. Cylindrical wavefronts are obtained when the source is line source of light. Plane wavefront is obtained when we move very far away from the source of light. The point which should be considered from here, that very important point, and that very point is the ray of light is always perpendicular to wavefront. Is it clear? The ray of light is always perpendicular to the wavefront. So this point is very important. So let me revise once again till now what we have done. We have done that the continuous locus of such particles which vibrate in same phase is called wavefront, Wavefront is of three types. One is spherical wavefront. It is made because of point source of light. Another is plane wavefront, when we move very far away from the source of light. And other is cylindrical wavefront, when the source is line source of light. Okay, so this is all about the wavefront. Let us move to the next topic. Okay, the next thing we have to study is how we understand the propagation of light in form of wavefronts. As we have studied, in the case of plane mirror, when a ray of light falls on the plane mirror, it bounces back. This phenomena is called reflection of light. Now, how we should understand this thing in terms of wavefront. So for wavefront, we draw two rays of light parallel to each other. They reflect parallel to each other. How the wavefront is being drawn? See, the rays are parallel to each other. Wavefront will be drawn like this. It is a surface. It is not line only. It is like this. So you are able to see this edge only. You are not able to see this plane. It is like this. This. And the reflected wavefront will be in this manner. Is it clear? Incident wavefront will be like this, and reflected wavefronts will be like this. Okay? When we talk about convex lens, suppose a ray of light is falling parallel to the principal axis, then it goes through the focus only, that we have studied in the ray optics. Now how we understand this thing in terms of wavefront? In wavefront, here the wavefronts will be like this. They are like this. You are able to see this edge only. You are not able to see this plane. They are like this. And after getting refracted from the lens, they become like this. Okay? For a concave lens, how the wavefront behave? This is your concave lens. When a ray of light goes like this, now they diverge from each other in such a manner that when we extend them behind the lens, they cut at a point. This very point is focus. Incident wavefronts will be like this. Refracted wavefronts will be like this. Is it clear? Okay. You have to take this point as center and you have to draw spherical wavefronts. Here you have to take this point as center and you have to draw spherical wavefronts. Okay. I hope it is clear. So in this manner, we have to study the propagation of wave in this chapter. The chapter is wave optics. Okay, let us move to the Huygens theory. Okay, what is Huygens theory? Huygens proposed that each point on a wavefront, suppose here is a source of light, we can draw so many wavefronts here. So in this wavefront, on this wavefront, so many points are there. So as per the Huygens, he proposed that these points on a wavefront, these points on a wavefront, act as a fresh source of new disturbance. Act as a fresh source of new disturbance. Means, suppose the source of light is there, so it has some property, it has its frequency, it has its wavelength, it has its speed. Okay? Means the light which is emitting from here, although speed depends upon the medium, Wavelength also depends upon, but frequency is the property of source only. And from here, in every direction the light is moving, in every direction light is going. So according to Huygens theory, each point on a wavefront, every point on a wavefront act as a fresh source of new disturbance. And this new disturbance is called secondary waves. Okay? According to Huygens theory, each point on a wavefront act as a fresh source of new disturbance, which is called secondary waves. And these secondary waves add up together to give the new wavefront. These secondary waves add up to give the new wavefront at any later time. Suppose we have to know the wavefront, the shape of the wavefront, the nature of the wavefront at some other time, after some time, then what we have to do, we have to add these secondary waves for a given time to know the new wavefront. Where is the new wavefront? In what shape the wavefront is going to be. Okay? The Huygens theory is based on the basis of some assumptions. What are the assumptions? Let us see. His first assumption is each point on a wavefront act as a fresh source of secondary waves. Okay, acts as a secondary waves. Second point, this is what his theory is. Actually, his theory is based on this assumption. His theory in a single line tells what his assumptions are there in 3 lines. Okay? Assumption number 2. The source of secondary waves have same property as the source has. Okay? These source of secondary waves has the same property as the source has. Means frequency. The light was spreading in all directions from the source in the same manner from the secondary wave source. The light will be spreading in all the directions with the same frequency. Third one is the new wave front at any later time is given by forward envelope of the instant wavefront. Okay? The new wavefront at any later time is given by forward envelope of the instant wavefront. What does this forward envelope mean? Let us see. What this forward envelope means, let us see. Suppose a given wavefront is like this. This wavefront is called, let us name this as AA dash. Okay? Now, we have to know the wavefront after delta t time interval. So what we need to do, we need to multiply with delta t with the speed of light, and then we are going to have a particular distance. Speed multiplied by time, we are going to have distance. Now what we do, we select some of the points over here. Each point behaves as a new source of light. So after d time, let us take we'll draw some circles by taking a radius d. So what we are going to have, a circle like this, its radius is d. A circle like this, its radius is d. A circle, actually these are the spheres, not circle, but we are drawing on the two-dimensional board, so we are calling it a circle, but actually these are the spheres. Okay, so we'll get some circles like this, we'll get some spheres. Now what we draw a common tangent of all the spheres together. So this tangent BB dash, it is called the forward envelope of the given wavefront AA dash. Is it clear? It is called the forward envelope of the wavefront AA dash, and after a time interval delta t, this is going to be our wavefront. So if this wavefront is known, AA dash is known, so we can draw a new wavefront which is at any later time, which was told in the third assumption. The new wavefront at any later time is given by the forward envelope of the instant wavefront. If we draw a common tangent behind the given wavefront, let us name this CC dash. So this CC dash is called backward envelope. Backward envelope. This was the shape of the wavefront delta t time before. This BB dash is called forward envelope. Forward envelope. And this is the wavefront after delta t. AA dash at this time present, BB dash after delta t, CC dash before delta t. Is it clear? So for any particular time we can draw the wavefront. I hope it is clear. So today what we have studied about waves. Waves is a kind of disturbance which travels through a medium. In this chapter we have to study non-mechanical waves. Then after we studied wavefront. Wavefront is the continuous locus of such particles which vibrate in the same phase. Then after we studied types of wavefront. 3 types of wavefronts were there. So, spherical, cylindrical and plane wavefront. Then after we have studied Huygens theory. Huygens theory says that each point on a wavefront act as a new source of light or fresh source of wave, which are called secondary waves, and these secondary waves add up to give new wavefront at any later time. This Huygens principle is based on 3 assumptions. First assumption is each point on a wavefront act as a fresh source of secondary waves. Secondary waves are also called secondary wavelets. Secondary wavelets, not secondary wavelets, wavelets. Another name is the wavelets. Okay, these sources of secondary waves have same property as the sources, that's the frequency. The light is spreading in all the direction. I am talking about those properties. Now the new wavefront at any later time is given by the forward envelope of the instant wavefront. Given wavefront, forward envelope BB dash after delta t time, CC dash before delta t time. This is all for today. Tomorrow we are going to study reflection and refraction of light on the basis of wave theory. I hope we have done reflection in the ray optics, but on the basis of wavefront, how we prove the law of reflection, law of refraction, we'll see tomorrow. Moreover, from the board, if you are not able to write down the notes, I am providing a link of PDF file which consists the notes of today's topic. Till Huygens theory, notes are there. Whatever our notes has been provided in the link, you have to note down in your copy. So this is all for today. We are going to meet tomorrow with new topic, and that topic will be reflection of light and refraction of light on the basis of wave theory. This is all for today. Thank you.